to hide or show pre-selected game objects. Hiding and showing objects can be used to allow the user to control the visibility of design options, to hide building parts, or to toggle the display of furniture. We will first collect a list of objects that we want to toggle. Then a toggle box will be displayed as part of our user interface. And finally, we need to traverse the list of objects to effectively hide or show them on screen. We start from the building model we already used in the previous sections. Check the hierarchy, play with the active checkbox and the mesh renderer component, which can be deactivated too. Both can hide objects, but will focus on the active state in our script. Create a new C# script and call it toggle objects. Open it in MonoDevelop. To be able to handle a list of game objects, we use an array variable. Write public class game objects with square brackets to indicate that it's an array, and as a name objects, and with a semicolon. Then we want to add a series of toggles for each object in our list, which we will use to show and hide them. This is done in the onGUI method. With the for each, we step through all game objects in the objects array. In each step, we can use the go variable to access the array item. So for each game object, go in objects. Close the brackets, open the curly brackets. We use GUI layout, which provides automatic placement of GUI items, so we don't need to add a separate rectangle statement here. The value of the toggle, which can be on or off, or true or false, will be the active self property of the object. And the text that is displayed is simply the name property of the object. Save the script and test it in Unity. We create an empty game object and drag the script to it. Now we can configure the array by dragging some objects from the model onto the list. Press play to test the script. You should see 3 toggles in the upper left corner of the game objects. But the toggles are not functional yet. Stop and switch back to MonoDevelop. We now add a bool variable with name active that captures the result of the toggle function. If this variable differs from the active self property of the game object, then we will toggle it with the returned value. So if active is different from go.activeSelf, then we call go the method setActive, and as a parameter the active boolean. This ensures that objects are only toggled when we effectively click on one of the toggles in the game view. Save and test again. Now you can hide or show the objects you configured in the array. Beware that this method activates or deactivates an object and all its children at once. This is easy to do, but also deactivates any scripts and other components that are running on these objects, so be careful what you toggle. In this video lesson, we learned how to change the active property of game objects in a script. We used the GUI layout toggle method to display the different toggles on screen and let Unity take care of hiding objects and their children. In the next video, we will make a script to switch between different viewpoints. This is the second video of section 7 on scripting. This video will let the user switch between different viewpoints by using different camera objects. You can use multiple cameras in a scene. However, if they are all displayed on the whole screen, they overlap. The approach we use is having a different camera in front with a high depth value and let it move smoothly between the other camera positions. We continue with our regular scene and add a few different cameras. We call them Cam 1, Cam 2 and Cam 3 respectively. Also, add an additional camera called Master Camera. For a better overview, we make all the cameras children of an empty game object called camera group. A nice way to position cameras is by finding a suitable view position in the scene window, using orbit and pen movements, and then select the camera and align it to the view using the menu, Game Object, Align with View. Create a new C# script called Switch Camera and open it in MonoDevelop. First, add an array to store our cameras. Public, camera with square brackets, and as a name, cameras. Also, add a single camera as master. Public, class camera, and as a name, master camera. Semicolon. In the start method, we step through the list of cameras and set each one's depth to -10. The master cam gets depth 1 to ensure that it is displayed above the others. Then we'll use a private integer variable called index to keep the chosen camera number. Set it to 0 in the start method and switch to the next index in the onGUI method when pressing a button. Use GUI layout, so you don't have to worry about button placement on screen. We'll use the same modulo operation as we used with the material switcher video. So if GUI layout button called next camera that returns true, we change the index, index +1, modulo camera's length. Almost there. We still have to ensure that our master camera is moved to the right place. Do this in the update method. Set the position and rotation parameters by copying them from the camera in the array at the position index. Save the script and switch back to Unity. Now drag the main camera, Cam 1, Cam 2 and Cam 3 to the camera list and set Master Cam as the master camera. Now press play. Hit the next camera button a few times. A possible improvement is to use LERP, short for linear interpolation, to move the master cam smoothly to the right position and rotation. LERP is a static method called from the vector3 and quaternion classes. With arguments from and to position or from and to rotation. And a small number to set how fast the transition will be calculated. By setting this in the update method, it gets refined continuously. Now save the script for a final test run. In this video lesson, we created a small script that allows us to switch between cameras at runtime. Use this to prepare some particular views on your product or design. You can switch between players or even to an animated tour of your project using an animated camera. In the next video, we take control over the player. This is the third video of Section 7 on scripting. In this video, we will control what happens when the player will bump into a trigger. This can be used to reset his position when he falls from the world or return him to a particular location in the scene. We do this using a trigger box. The position and rotation of the player can be stored automatically, but we also illustrate an alternative using a custom spawn point, as it is often called in game terminology. We use a simple scene with a building and a third-person character as the player. Just ensure that the player correctly received the player tag. Create a new C# script, call it reset player, and open it in MonoDevelop. Create 3 private variables: private GameObject player, private vector3 pos for position, private quaternion rod for rotation. Vector3 objects keep XYZ positions, while quaternions are an equivalent class for rotations, but they are mathematically a bit more complicated for numerical robustness. However, we don't have to bother about their implementation. In the start method, we query our scene for the player object using the findGameObjectWithTag method, which can be called from the GameObject class. As an argument, use the player string, which was the tag we set up initially. With this object, it is trivial to store the initial position and rotation in our 2 private variables. This is nice as there is nothing we have to set up. There are no public variables at this point. This script will work from a trigger object, so switch to Unity, create a simple cube, and set its collider to isTrigger in the inspector. Back in MonoDevelop, we need to also implement the onTrigger method, which is called whenever an object passes through the trigger. First, check that it is the player who hits the trigger by comparing the tag of the collider with the player string. If other GameObject compare tag player, if that is true, then if that is the case, we can simply recall the pos and rod variables to move and rotate the player back into his original position. Save the script, switch back to Unity, and drag the reset player script to the trigger cube. No need to set up variables, just press play. Walk towards the cube and notice how the player is placed back onto the original starting position. And because of the third-person camera script, you get a smooth camera movement for free. But we can improve our script further. Switch back to MonoDevelop. If you want to move the player to a custom spot, add a new public GameObject variable called custom spawn point to the script. In the onTrigger method, you can check for the availability of this variable. If it is not null, which means if it exists, then use the position and rotation from it. To test this, now you do need to add an object to the public variable field. You can use an empty game object, as not to obstruct the player when resetting. Here we place the spawn point on top of the roof of our building. To visualize the custom position, you can use a color indicator from the inspector. This makes the empty object visible in the viewport of the editor. A final save and test should confirm that the reset trigger works as expected. In this video lesson, we set up a system to reset and reposition our player by using triggers. We also learned about retrieving particular objects from the scene using a tag. In the next video, we look at picking objects on screen when running the project. This is the fourth video of section 7 on scripting. In this video, we'll learn how we can pick an object on screen. This is useful to select an object for more information, such as displaying material, cost, or structure data. Picking objects can be done casting a ray, which will traverse the geometry and return the closest object it collides. The resulting hit point can be queried for certain feedback, such as which object was hit and at which point. And finally, to give some visual feedback, we display the name of the object to the user in the GUI. This approach works with any scene, so we continue from our last model. There's nothing in particular to set up, apart from the fact that you can only pick objects which have a collider geometry, like a box, sphere, or the geometry you imported using mesh colliders. We already generated colliders from the FBX importer settings, so we are good to go. Create a new C# script and call it pickObject. Open it in MonoDevelop. In the update method, we will start by checking if we hold the first mouse button down, which is usually the left mouse. This is called from the input class, and we check for button number 0. Input dot get mouse button, open the brackets, 0, close the brackets. Next, we set up array and arrayCast hit, which is a structure that is returned by the arrayCast method. When we cast array, we do this as a line between our viewpoint, which is the camera position, and the current position of the mouse, which also conforms to a position in the 3D view plane of the camera. We use the convenience function screenPointToRay and call it from the main camera, as provided by the camera class. As argument, we use input mouse position. The execution of the arrayCast is done by the physics class, and the empty hit variable we created will be filled in, if the function at least answers with a Boolean true value. The number 20 is how far we want our array to be cast. If we pass the if control, it will contain several parameters. The normal of the geometry at the hit point, the distance from the starting point of the ray, and the objects with which we collided. To check what we are doing, we write a debug log message containing the name of the collider we hit. Now we can save the script if all brackets are correctly closed. And in Unity, attach it to an empty game object called GUI. Press play and click into the scene, while keeping an eye on the console or status bar. You should see the debug message appearing each time you click onto an object. However, we want to present this information to the user, as the console is only usable during project development. So keep a private variable to maintain which object has been picked. Private, game object, hit object, semicolon. When we pick the object in the update method, set a variable to the object we just picked. Hit object equals game object. If we did not pick any object, we have to set the hit object back to null. Do this in the else part of our if control statement. In the onGUI method, we display a box with the name of the object, but only if the hit object is not null. Get the name of the hit object and use it as an argument for the label function of GUI layout. No need to set up size and position with GUI layout methods. When we save the script and return to Unity, we can now check if it works fine. Press play and click on some of the building elements. Their name appears in the upper left corner and stays there until we click on the background or hit another object. This is not perfect and graphically it could be refined, but the basic mechanism is now implemented. By the way, since we check for the first mouse button, this approach also works on mobile devices, as a touch on the screen is also registered as a left click of the mouse. In this video lesson, we implemented object picking using the raycast method of the physics engine. We retrieved information from the... This is the fifth and last video of section 7 on scripting. In this video, we expand our script from the previous video and not only display the name of an object, but also check for additional custom data that we attach to it. We will create a simple script to add a few additional variables to an object in a custom component. When we pick an object, we can retrieve this information through the component and will display it in a pop-up window properly centered in the screen. Just continue with the scene from last video. In Unity, we create a new C# script and call it object data to store some information about the building element. Open the script in MonoDevelop and simply define a few public variables. Public, string, short name. Public string description, and public float total cost. If you add the multi-line between square brackets statement directly before the description variable, the text will display it as a multi-line editing text. Save this script and attach it to one of the main wall objects in our model. Since object picking is only possible with colliders, we need to ensure that our data is attached to the mesh object that has the mesh collider and not on one of the empty parent objects. Write in a few strings to define the data. Now we need to adapt our pick object scripts we created in the previous video. We go straight to the onGUI method and expand our code a bit to retrieve our custom data if available. First, on the hit object, use the getComponent method to retrieve our custom component. The syntax itself is a bit particular. GetComponent, use angular brackets with the proper class name object data and curved brackets without arguments. We also have to check if this component actually exists, in case we did not add the object data script to a particular object. It is easiest to assign this to a variable of this class so we can directly request the properties. And to be able to access the variables of this class, we need to cast it into the object data class. Finally, we simply add a few GUI layout label statements to place different parameters on screen easily. GUI layout, label, then hit object name. Do the same for data short name. Data description, data total cost, and translate total cost with this toString method into a value that can be displayed in a label. If no object data is retrieved, we simply use the name of the hit object. Save the script and play the scene. Click on one of the objects to which object data was attached. You should see the additional parameters when available, and only the object name if no custom object data component was retrieved. Here we first calculate 1/3 of the actual screen using screen.width and divide it by 3. Assign this to a local variable screen_third. To center our text labels, we can group the labels in an area. Place GUI layout begin area before the labels, and as argument, we define the required size using a rectangle. New rect screen_third. This is then used to set the rect position and width. You have to end with a call to GUI layout end area without argument. You can even make some of the text editable by replacing the GUI layout label with a GUI layout text area. However, you need to ensure that the return value of this method will be assigned to the actual data description value, so it can be overwritten. We also added a min height option, so the field has some height. This keeps the edit text as long as the project is running. To actually store it permanently with the model is beyond the scope of this particular video, alas. Test the final version of our script and try to edit the description field for the selected object. In this video lesson, we enhanced the pickObject script to add custom object data and displayed it on screen. We also made a description value editable, which could be used as a primitive commenting system. This concludes section 7 on scripting. The next section will turn our Unity project into an actual application that you can share.